All right, welcome to week one. I'm on the wrong slide to start this video off, but we're going to go with that. So week one of 374. We're going to start off our topic today, or one of the topics for this video is going to be strategy for solving applications of linear equations. And so we've got these 5 steps here that we kind of want to keep in mind. So you can kind of abbreviate them down, like step 1, read the question carefully, identify the variable x. Step 2, identify any expressions that you might be able to create from the scenarios inside of the word problem. So remember, expressions are things without an equal sign in it. Step 3 is try to take those expressions and model what's going on in the problem. And when we do an example, that'll make more sense. Step 4, go ahead and solve the equation to answer the question's problem, the problem of the question. And then step 5, check your work. Always making sure that you didn't actually misread something. Maybe you thought it said add, but it really was a subtract, or you thought it was divide, but it was really multiply. So just check to make sure that you have the right solution. And then if not, you can always make modifications. All right, so here we are. This first one, I just left all the work up on the screen. And so remember they said start off by reading the question carefully and identifying what X represents. So as I read this question, what I realize is I have 2 rental car companies. One has an initial fee of $20 with an additional charge of 5 cents per mile. Company B has 5 cents fee with 10 cents per mile. And so the question is when will I get to exactly the same amount of money spent? How many miles would it take me to get there? So how many miles right there, that's what I'm looking for. That's what X is going to represent. So X represents the number of miles. So when I work this problem, anything you see written on the paper on the screen right now, these are the things that I will be writing down on my paper to help me remember like what I've identified, what I'm solving for. So X is what I'm solving for. In this case right here, my outcome that I'm going to be getting, and I'm just going to put a Y there. We're not going to have a Y in this equation, is going to be the money, right? It's like that's how much it costs us to rent this car. All right, so part 2 is write expressions. And so we've got company A. And so in company A, we have an initial fee. And so what I like to do is I like to help me understand what I'm doing here is I'm going to make a little T-chart where X is my input and Y is my output. Remember, X is my miles and Y is my money. So if I drive this car for 1 mile, I rent this car, I drive it for 1 mile, that means that I'm going to pay $20, right, for the car, plus another 5 cents for that 1 mile. If I went 2 miles, I'd pay $20 plus 5 cents times 2. So this is helping me understand, that makes sense. I have the right expression. So by plugging it in and testing it out like that until you become comfortable with how to create the expressions, that's the best way to me to kind of model the behavior of the expression to make sure I'm doing the right thing. So I feel pretty confident about that. And so I can say, okay, if that worked for A, that must be very similar for B. So now we've got our 2 expressions. Awesome. So now step 3 is to write an equation. And I'll be right back. All right, and so now we have our equation. So our equation is nothing more in step 3 than to actually just put the 2 expressions together. Well, how do we know that we're setting them equal to each other? Well, remember, that's what we're trying to find out, is we're trying to find out the scenario where we have company A is going to be equal to company B. So we're looking for the number of miles, that's our X, of company B, that will give us a number of miles, and that's our X of company B, where their dollar amounts will be exactly the same, right? So that's what we're trying to find out. We're trying to come to that, all right? So with that said, and this is a familiarity thing, it's sometimes in problems, you add them together and they equal something. Sometimes you subtract them and they equal something. Sometimes you set them equal to each other and then you solve, so it's there's different scenarios. And so we may find, similar to this on some of the problems you're going to do, or it might be slightly different. All right, so we set them equal to each other, and let's do a little algebra together. Maybe it's been a little while, you're rusty. So set the equation up here. So 0.05x is equal to 5 plus 0.10x. And then we start solving. So let's just move the x's first, right? And so this is 5 cents, that's 10 cents. So I'm going to subtract the 5 cents over here to be able to get those two guys, or get all the x's onto one side. And so I read the problem from left to right. So I come to the left. I haven't used the 20, so I bring it down. The 5 cents cancel, or the 5 x's cancel. I bring down my equal sign. I have 5, and then I have 10 cents take away 5 cents, and so that's going to leave me with 5 cents. All right. Next guy is I'm going to move my whole number, my 5, over with my 20. So what I've done is I've isolated the x's using addition and subtraction. So those should be gone. That gives me 15 is equal to 0.05x. The inverse of multiplying is to divide. So I divide by 0.05. I divide by 0.05. And I come out with x is equal to 300 miles. So this is the x amount that I am saying is going to give them equal amounts. That's when the companies are going to be exactly the same. So step 5 is to test that. So step 5, I'm going to come up here and I'm going to plug in my values. So 20 plus 0.05 times 300. Remember, that's how many miles we think that we would drive to be able to have the rental cars be exactly the same. I like to put a question mark there to remind myself I'm not really sure if this is true or not yet. And then 5 plus 0.10 times 300. All right, on the left-hand side, we plug that into our calculator. We find out that that's $35. Wow, that's cheap for a rental car. And on the right-hand side, we find out that's equal to 35. So check, we have the correct value. We know that it is going to be $35 for each car if we drive them at 300 miles. That's find that spot. So let's just real quickly draw a quick graph and kind of talk about what that means. So if this is my x-axis, and that's a bad color. If this is my x-axis and that represents miles, and this is my y-axis and that represents money. And now, please forgive me, I'm not going to put scale on this. Okay, so the first equation starts at 20. So let's just say 5, 10, 15, 20. It starts right there. And it goes up by 0.05. So I'm just going to kind of draw a line that kind of looks maybe like that. All right. Second company starts at 5, but it increases at twice the rate. And so what we just found out is we found out this location where car company B becomes the same price and then starts getting more expensive, versus company A has been the most expensive, but now at this point, company B actually becomes a less expensive company. So this point of intersection is a really interesting thing in math. This is kind of a topic that you want to make sure your kids wrap their heads around. All right, so we're going to go to a couple more examples, or at least let's do one more example. So I'm going to hit pause for 1 second and get myself ready to go, and we'll come back with a second example. All right, here I'm back. What I'm going to ask on this one is that you'll notice that there's nothing written here on the screen. And so as far as the steps or the things put in place, so I don't want you to kind of just treat this question as you do the steps. You read the question, you identify your variable, you identify your equation, and you try to do the process. And when you get stuck, watch the video to that spot to fill in the blank that's caused you to be stuck. Then hit pause and try to keep going. All right, so does that make sense? So you're gonna do this on your own, but when you get stuck or you're unsure, watch the video to that spot, figure out that gap that you need filled, then hit pause again and keep on working. All right, here we go. So welcome back. So you hit pause, right? I said that wrong, sorry. You hit pause, you work the problem, you're walking back, you're gonna watch me through. All right, so here we go. So step 1, I'm gonna read the question through. Your local computer store is having a terrific sale on laptops. After a 40% price reduction, your purchase of a new laptop is $552. What is the laptop's price before the reduction? Okay, so that's X. X is equal to the price. All right, so X is equal to the price, or also known as your original price. Oops, sorry about that. or also known as your original price. All right, now we know that we have a price reduction. All right, so there's different ways we could work this problem, but because we're looking for the discount would mean that we're going to take 40% of this price of this laptop. So X is representing the laptop, but now the laptop's on sale, and the sale is 40% of that. So remember, when we use percentages, we change the percent to a decimal. We move that decimal 2 places to the left, and we get 0.4. So the sale price, or the discount, not the price, the sale price is going to be 0.4, or 40% of X. So our discount is going to be 0.4X. That means to find our final price, we're going to take our 100%, which is our original, minus our 40%, and that's going to give us our final thing, which is 60%. So that means we're going to take the X minus the 0.4X, and that's going to be equal to 0.6X. All right, works so far? Awesome. All right, so our equation that we're going to get is, we have right there, we already started it, so that's our original price, that's our X, minus our discount, which is 0.4X, and that's going to be equal to our final price. So after the price reduction, the purchase of a new laptop is $552, so that's our $552. And so we keep on simplifying. So now we're at that, what would that be? So let's see, we go back up here. So we write our expressions, we've written our equation. Notice in this equation, it wasn't a situation where we set anything equal to each other. It was all about finding out what we want to set it equal to through the words in the problem by reading it carefully. We set that equation up once we identify those things, and now we're going to solve and check. All right, and so here we are, we're back. And so now we start solving. I already did a little bit of math right there. So we find out that's 0.6x, because this is 1, right? That's 1x, take away 0.4 is 0.6, is equal to 552. We divide by 0.6 to get our x by itself. I grab my rusty trusty calculator. I take 552, I divide it by 0.6, and I find out that the original price of this computer, sorry about that, was $912. Last step is to check my work. So last step would be to go and plug that back into the problem. So remember, we have this equation, so we can go back and use this equation right here, which is kind of silly because we'd have to plug in x twice, or we could use this equation right here because it's exactly the same thing, just in a simplified form. So when we check, we're going to take 0.6 times 920, right? So 60% of the original price should be equal to the sale price, right? So then this is a question mark. We're checking it. We grab our calculator. We take 0.6 times 920, and we get 552. So we find out that 552 does equal 552. And so we have correctly solved this problem. Check. All right. One more example on this topic, and then I'll let you kind of run it the same way. But all right, we're going to run this one the same way we did example 2. Once again, I really hope that you're working these problems. This is part of the learning process of this course, and I'll explain that when I meet with you guys for the first time. But this is part of the learning process for you to take the time to work through these on your own, and then have the tutorial video like we would be doing this in class. All right. So same thing. You're going to work this problem. If you work it all the way through to completion, then you hit pause, or you unpause it, and then you watch it through, or just fast forward to the end to see the solution. And then if you're good to go, then you're done with this video. You go on and you can work on the problems for the week. If not, you can come back, watch the video, figure out what's going wrong, send me questions, whatever. All right. So back to it. So you're going to hit pause right now. If you get stuck, you're going to unpause, watch the video to that spot, check your work, see where your error might have come from. When you find out your error, hit pause again, try to fix that problem and continue working the problem, and continue that process of, as needed, watching the video. Don't watch the video through. I don't want you just to watch the video and copy the work. I want you to try this question on your own, please. All right, here we go. So I'm going to hit pause. You're going to hit pause. When you need help, you'll unpause. All right, welcome back. Hopefully you were able to work this problem all the way through to the end without needing any help. But if not, here you are. Let's jump into it. I'll work through it. Remember to hit pause when you get to your spot. All right, so read the question carefully, identify the variables. Woodworking project calls for 3 pieces of wood. So I see that right there. I'm thinking, okay, it's 3. The longest piece, so I got the longest, must be twice the length of the middle. So there's my second one. And the shortest piece must be 10 inches shorter than the middle piece's size. If the 3 pieces are cut from a board 70 inches long, how long can each board be? All right, so we have 3 things. We have our longest, we have our middle, and we have our short. The deal is that we still use one variable. It's not that we have 3 variables in this equation, in this situation. That's going to be a completely different type of word problem. So x is represented by what? That's the question. So let's see if we can't figure that out. So we're looking through here, and we find out that x represents the longest piece. Right? Because the longest piece must be twice the middle piece. That's not correct. Let's go back and check that. Give me 1 second. So it can't be the longest piece because the longest piece is twice the length of that's right, the middle piece. So that's not going to be true. Oops, sorry about that. Wrong thing. And so that's going to be the middle. All right, so that's going to be the x. So then what's the longest? Well, the longest is twice the length of the middle. So the longest is 2 times the middle, and that means that it's going to be 2x. The shortest must be 10 inches shorter than the middle. So the shortest one is the middle one minus 10. So that's equal to x minus 10. All right, and so now we're ready. We have our 3 expressions. So we have expression 1, expression 2, expression 3. Now we need to take those 3 expressions and figure out what we're going to do with them when we make our equation. And so it says, if the 3 pieces are to be cut from a board that's 70 inches long, how long can each piece be? And so we're assuming that we're going to use all of the board, right? So we're saying that, like, if we have these 3 pieces of wood, we're going to use all 70 inches. So that means the 3 pieces of wood are going to add up. So we have our longest, that's our long one, plus our middle, plus our short is going to be equal to 70. And so plug that into our equation, and we get 2x plus x minus 10 is equal to 70. So a lot of you are coming off being fresh off of algebra stuff. You know, this is an issue for you with algebra, but I'll just kind of review it. We combine like terms first. So we have 2 plus 1 plus 1. That gives us 4 x's. Take away the 10 equals 70. Bring down everything we haven't used. And now we start solving. The inverse of subtracting 10 is to add 10. So we add 10 to both sides. And we find out we have 4x is equal to 80. The inverse of multiplying is to divide, so we divide by 4. We get x is equal to 20. So that means the middle board is equal to 20. So let's go find those lengths. So we know at this point that the middle is equal to x, which is equal to 20. We have the long, which is equal to 2x, which would be equal to 40. And we have the short, which is equal to x minus 10, which would be equal to 10. So to check this question, we set an equal sign there, put a little plus sign, we add those all together, and we find out that those boards would add up to 70. Check. So that's our check to make sure that we have the right expressions, we have the right value. So the question is, how long can each board be? And here it is, 20 for the middle, 40 for the long, and 10 for the short. All right.